Hey guys, good morning. Welcome to today's webinar on mastering Agentic AI for CPG in 60 minutes. My name is Anushka Anjali and I head marketing operations at Bizom. I'll be your host for the day. First, a big thank you for joining. We have a fantastic mix of CXOs, sales heads, IT leaders, and RTM experts from across major CPG brands across the globe. Today, you'll see how RI agents work across multimodal inputs, which include voice, image, video, text, how they compress user journeys, eliminate manual audits, and produce perfect execution from sales calls to distribution to merchandising. Before we dive in, let me quickly walk you through how today's session is structured. We'll start by grounding ourselves in AI realities, specifically the difference between generative AI and agentic AI. There's a lot of noise in this space right now, and it's important to separate what looks impressive from what actually works in the real world operating environments. From there, we'll zoom into a very practical example of the summarization agent. We'll cover what it is, what problems it solves, and why summarization becomes critical when you're dealing with high frequency field and distribution data. Next, we'll step back and talk about where AI truly adds value, and just as importantly, what to watch out for when taking AI from POC to production. This is often where initiatives struggle, not only because the models are weak, but because scale, reliability, and operational fit become real constraints. This naturally leads into how we think about AI at Bizom. We operate at a massive scale, millions of outlets across markets like our home India, APAC, and Europe, which means every AI capability we build has to work under real constraints like infrastructure, cost, latency, and adoption. All of our RI products, including what you'll see today, are built under a shared umbrella of these best practices. Finally, we'll bring everything together with a live demo of Bizom's summarization agent and RI Copilot, showing you how agentic AI is already being used to support field sales and distribution teams, and how it translates directly into better and faster execution on the ground. By the end of the session, the goal is for you to walk away with not just an understanding of agentic AI, but a clear sense of what it takes to make it work at scale. Joining us today is a leader at the forefront of Bizom's contribution to India's CPG transformation. We have Mr. Rohit Agarwal here, who's the Chief AI Officer of Bizom. With 16 plus years of experience across retail, healthcare, and life sciences, Rohit sir is a pioneering AI and data scientist leader who built Bizom's data science function from the ground up and leads breakthrough work in image based store verification, predictive analytics, and AI led RTM intelligence. Welcome, Rohit sir. Let's get started with the session.
So, yeah, thanks everyone for joining the session. So, I'll start with a simple question. What is generative AI as per you? Because there has been a lot of noise in the market, and there's often a confusion what to call as generative AI or Gen AI, or what to call it as a agentic AI, and that's a kind of a confusion that we want to remove in today's webinar. So, if any thoughts, I would be happy to know. Um, else, let's start. Uh, so, let me start with a very simple example that you might have witnessed in day-to-day life, like when you type email. So, this is a screenshot from Gmail Compose application. And when you say thanks for letting, it automatically shows you the complete sentence. Now, this is an example of a generative AI, where basis of what you have written, it is telling you what is the next set of words. Or to little bit put it more formally, given the set of words, just take a pen. Given a set of words that have been seen, what is the next word for me? And this happens through a set of algorithms which falls under the umbrella of neural networks, where you have this stream of words and it predicts what is the next word. Uh, so here the concept is that you are generating something. You are generating a new word which is based on the previously seen words. Similarly, in the case of images, suppose you give a prompt saying draw a picture of dog sitting on a sofa. Now, basis of this prompt and the previous pictures that it has seen, the algorithm has seen, it tries to figure out what can be the next picture, which will have the sense of what you are asking. So the context or the initial set of words or the images that you give becomes the the output or the input for the next image that has to be created. Now this is all falls under the generative AI umbrella. Uh, Also, we need to understand why it can handle or why generative AI has become so powerful these days. So the issue with the issue that happened like a few years back was that the language was not understood by the algorithms pretty well. So for example, if we look at this sentence, and it is a very popular sentence, animal did not cross the street because it was too tired. Now it is very difficult to understand what does it refers to. It can refer to a street also, or it can refer to an animal also. Now, so this becomes an important consideration while we are training these algorithms. Another important example would be the meaning itself. Like I went to the bank to withdraw money that was next to a banking road and left to the bank of a river. So now the word bank has three different meanings. Now, how does the algorithm understand which meaning to use? This again becomes an important factor while training the algorithms. So basically, the complexity of the language lies in the words that are seen, and how many words you can see. So, for example, the movie was awful. The good thing was it was short. Now, if you look at the first part of the sentence, um, and you look at the second part of the second part will say good thing that it was short. If suppose I only look at this part, my assumption might be different, but if I look at this part, the assumptions is totally different. So we need to look at the full sentence to figure out what is the right sentiment of this sentence. Now, previously the algorithms could look only four or five words, and that is why their output would be a little bit confusing. But nowadays, because of the capabilities of algorithm, we can look at the full sentence to draw the inference whether we should classify it as a good sentence or a bad sentence. So these are the kind of complexities that we are trying to build in the models of the day. And then there are a lot of different kind of data sets that are used to train these models so that you get so much of accurate outputs. So when you write these days, you can write any kind of prompt and you get a almost right answer. And this is because that the models know the world knowledge, so as to say. And this all is to train a language model. Now let's see where the agentic AI part will come into picture. Now suppose I ask a question, plan a 7-day trip to Italy from Bangalore. Now LLM can generate a very good itinerary for you because LLMs have been trained on a lot of travel logs and a lot of magazines where the itineraries are given for different countries and so on so forth. So this is a very easy problem for a LLM to solve or a generative AI. So when I say generative AI, it means LLM, a large language model, a model that knows how to write English sentences or any language sentences. Now, let me just make this statement a little bit more complicated. Plan and book my 7-day Italy trip under $3,000 with stays in four-star hotels near historical landmarks. Now, there are multiple things that we are talking about. We are talking about a budget, we are talking about hotels, and we are talking about historical landmarks. So now the problem is that see LLM can also be considered as a zipped file of an internet. And this is a very popular statement by one of the leading scientists, Andres Karpati, who says that LLM is like a internet available to you, and you can just search very fast. Um, Now, the problem is that a lot of things that you are asking for in this particular sentence are dynamic in nature. Like, for example, I might not know what can be a budget, so I cannot have a knowledge of saying that if you ask me $3,000, I will give you this kind of an itinerary. If you ask me $2,000, so there are lot many permutation combination, and it doesn't make any sense for a model to learn all those things. Now, hotels can again be little dynamic because new hotels keep coming. Also, their ratings keep changing. And when we say ratings, these days ratings are not the actual accreditations given by the hotel industry, but these are the accreditations given by the people like us through travel logs and all those things. And yeah, so and there is a distance also to be taken care of near the historical landmarks. Now, these maybe few of the things can be solved by LLM, but most of them will not be. And that is where the agentic AI comes into picture. Whenever we want something dynamic in nature, whenever we want something that can be uh, searched from the web and then the knowledge can be built upon, that is where we need somebody to do those dynamic tasks. So, in the agentic approach, what will happen is that LLM. So the LLM part will only try to understand what is the intent of yours. So because LLMs are like English professor, they understand the language very well. So they can understand what you are actually trying to ask for. Then there is a thing called as reasoning, where it will decide, can I answer it myself, or I need to get some help from the outside world. So I have determined that I need a help, but how to get that help? So I need some tools or some kind of a functionality that can be called upon. Now, so I can automatically call certain APIs which will give me flight prices, which can check the hotel availability, restaurant reviews, and all those things. And then when everything is now fetched, or I have everything, now LLM can again come back and say, now these are the pieces that I have got. Let me stitch it together and make a new itinerary, which will have these dynamic parts also. So this is where the agentic approach will come into picture, where you cannot work along only with the static information that is available in the LLM during the time of its training, but you need certain dynamic aspects also. um, and this is a small diagram to just to summarize that if you are just asking for some very static information, or if you are just asking an LLM to do this, it will just, if it can maximum give you web pages. Here are the web pages, figure out yourself. But if you really want to get the answer, the final answer, then you need certain tool calling. Now, there might be a question saying that I use ChatGPT and everything is done. Then where is the agent part? So ChatGPT is kind of a abstract layer on top of the agentic AI. They have automatically created all these decision points where if you ask certain dynamic question, they will be searching in the background and giving you the answer which is built on the dynamic information. If you ask a static question, they will give you a static answer. So chat gpt does it automatically, hence you feel that everything is gen AI or everything is agentic AI, but this is the difference between the two. Now let's understand a little bit of under the hood thing. What all elements? As I said, these are the element. These are the theoretical elements. But how do we place them while designing the agents? Uh, so the way we define the agent is like a software architecture where there are pieces that needs to work together. So there is the LLM, as we said, that this is the guy who is going to understand your query, and it is going to answer based on your query. Now there is a reasoning aspect. Reasoning aspect is mostly the configuration or the capabilities that we need to define for the LLM. We need to tell in what directions you need to think about, or what are the things that you can do and what are things you cannot do. So these are the system. These are written in the system prompt, and that works as a reasoning part. And then there is a tool call. So there is the ability of LLMs to call the APIs, and this ability is gained through a new layer called as MCP. So this is an external, I would say, integration piece, which uh, which gives you an access to a lot of these APIs that are available to fetch the flight, to do the internet search, and so on and so forth. Now there can be a question that there is something called as a REST also. Why do we need another guy called MCP? MCP, the way MCP has been designed is that it kinds of makes it, or it advises the API writers to give the description of the APIs in a more with some examples, with some intentions and everything written, so that it can be read by the LLMs. Because LLM cannot know the what this API is doing unless and until it has been properly documented. So MCP is one of the protocol which is trying to make these things mandatory, kind of. And once these APIs are documented properly, MCP will give you a list of APIs as part of the tool calls, and then the LLM can decide which APIs to call for. And the very important thing is a feedback loop, which helps the LLM to understand whether the answer has been reached upon or it is still some parts are missing. So in the previous query, where we said that plan a trip and all those things, so maybe in the first tool call, it only got the hotel details, but it did not get the flight details. So it has to see whether all the parts of the questions are available or not. If they are not available, then it will again make a tool change. So this is the feedback loop to make sure that everything is correct. Now, now let us see how a generative AI solution can become an agentic AI solution. So let me just give a sense also. So when do you say that this solution is now a agentic AI solution? Suppose the problem is that there is a restaurant receipt and you want to just figure out how much tax was paid and how much the total amount was, and you want to do a OCR kind of a thing because you have a paper bill and you want to insert it into the, say, Excel sheet. Now you have an OCR model or an API that you are running on this receipt, and you get some strings. So OCR will just give you some English strings or the numbers and whatever it could figure out from the receipt. It will be just giving you as a raw text. Now you pass this raw text to LLM and you ask a question. Given the text string, find out the text and the total amount paid, and the LLM hopefully can figure out all these things. I said hopefully because the prompt has to be fine tuned, and maybe certain portions are not read properly. So again and again you have to do this. Now all these steps are very manual. So you need to understand that there is a OCR model. You need to understand that there is a string that has been figured out now. Then you have to write the prompt, and you have to monitor that the answer is correct or not correct. So this is, in this case, the LLM is only used to fetch to basically read the already present string and create a or extract the information that was asked for. This is a generative AI solution because there is no feedback loop, there is no intelligence from an LLM point of view. All the intelligence is external, which is basically you as a human providing that intelligence that you need to do more. LLM is acting like a tool here. Now let us just convert this into an agentic solution. So to make it agentic solution, what we need is that we need some reasoning component, as I said. So in the reasoning component, we will say that you are an LLM, and your capabilities are to understand the strings and figure out what is total, or you are capable to understand what are the financial documents. Such kind of things we will say. And tool calling will help the LLM to make the call automatically whenever it feels that it needs that call to make. So now when I say that here is the receipt and I need the total and the tax paid, LLM will automatically figure out that I need to make a tool call to an OCR model to understand what the receipt is saying, and then whatever string has been retrieved, basis of that it will try to figure out the answer, and it will have a feedback mechanism to see whether it has got all the points or not. So suppose in the first go it could only read the text and it was not able to figure out what is the total, so it might again relook into the strings and then figure out that okay, this is the line where the total is given. So the feedback will be automatically done, and so we could convert the generative AI solution into an agentic AI solution just by adding few of the elements to it. So the idea was to tell what is the difference between the two approaches in a very clear manner. Um, Now, another question that might occur, and it is commonly asked also, that if everything is so great, then why the agentic solutions normally fail from a implementation point of view or from an ROI point of view. So, as we see, there are four reasons to it. One is a FOMO problem. Like a lot of people are trying this agentic AI projects or the the approaches just because the other guy is doing it. So because the world is going crazy about it, so I should also do it. And so I don't know what is the output or why it is being used or anything like that. Somebody told me and I'm using it, and that's the point where I don't understand what is the benefit I'm going to get. And this happens with all the like lot of technologies. I might not be aware of a lot of things which I just try it out but then feel that they're of no use for me, and that's where it fails. The second thing is that a lot of time we feel that we can just use an LLM, ask some question, and it should be able to help me. But there are certain domain complexities, and we will see these examples also where LLM might not have any understanding of your domain. See, LLM is like a language model. It only understands English or maths or whatever data it has been trained on. You can ask some questions, it can answer you. It can answer in a very generic way. But if you ask a very pointed question, it might not be able to answer you in a proper way. And the problem is that it has not been trained on your domain. So you cannot ask like what will be my sale tomorrow. He doesn't know what is your how you calculate the sale and all those things. And that's where the LLM start failing, and you will start losing the interest in the power of agentic AI. Third thing is that LLM cannot be used for everything, because the important thing to note is LLM is based on a probabilistic model. Oh, based on the context, it is trying to predict what can be the best answer for me. You ask the question multiple times, you will get different answers, and that's the beauty of LLM, because that allows it to become creative in nature. You can give this a text, and you can ask, please rewrite it into three different ways. It will rewrite it into three different ways. That's the purpose of LLM. Now we cannot use this thing to solve every problem, because some problems need very deterministic answer, some problem needs a creative answer. So that is again a problem, that somebody will say, I have invested so much in LLMs, why are we not using it for everything? So that's again a problem. The third is that there is a there so and this is not regarding LLM, but this is regarding any intelligent product, where the expectation is that whatever is the answer, it is 100% correct. But every model has little bit of inaccuracies. Like I always say, there is this famous soap ads which come, that now we have launched a soap which can remove 99.999% of bacteria. So there is still a scope of improvement. So the same way these algorithms are there. There is always a scope of improvement, and it is never 100% answer. So we need to understand where we have to trust these algorithms and where we not should not. And if we understand these things, I hope that the there will be little bit better acceptance of these projects. Now let's get into some practical aspect of it. So we need to see three things. One is that how Bizom is making use of agentic AI. What are the practical issues we see while implementing agentic AI at scale, and how do we mitigate them? So we have come up with some kind of a design principles that we follow, and we also recommend them, and that can help in making the agentic AI journey little easier. Um, so let me just describe the Bizom agents, and then we will see how they have been created. So in Bizom, there is a screen where a person can take orders, or so he goes to the shop, and he wants to understand what is sold in this shop, for example. So he clicks on a button called as start call, which is basically that I want to now start my transactions in this particular outlet. And when he clicks on that button, a small outlet summary comes up. Now, this summary is something which is telling him about this outlet, like how this outlet has been performing in the past, what can be sold today, or is it a outlet which is showing a growth, or it is showing degrowth, stuff like that. Now, all this thing is actually coming basis of the data that we have seen in the past, and we are trying to aggregate the data and show him in a easy to understand language. Uh, and along with this text, we also show a small image of our mascot called Rio. And a happy Rio will mean that this is a good sign, or the text has a good sentiment. Uh, uh, Not so happy or an unhappy avatar of Rio will show that it is not a good scenario today. So now the things to focus about is that how did we generate this text and how this image has been generated. So we will focus mostly on the text, and image is like just a follow up on the same approach. And again, to make this thing more complicated, we can also see that there can be many ways of summarizing this information. So sometimes we might be showing which are the top selling SKUs in this particular outlet, or which SKUs have shown poor rotation. So there can be many kind of information that can be placed in this summary agents, and we will see these summary agents in more details once the demo part comes up. I'm just giving pointers of what is there in a agent. Now, how can we build this kind of a thing? Now, a very naive approach would be that, and this is a pure LLM based approach. So somebody says that I want to use LLM to their fullest. Now, how that approach will look like? So I have an LLM, NLP prompt which says that I want a output which has got the growth trends, what is selling here. So I will give a list of things that I want to know from this outlet. Okay. Now this list of things has to be fetched from the database, and the database language is SQL. So there is a element or the tool which is NLP to SQL, which is again a kind of an LLM model which understands the NLP, which understands your English text and can convert into a SQL query. Now, once this SQL query has been created, it will go to the database, run in the database, fetch the results, and give it to you. Give it to the LLM. Now, LLM is going to again analyze that entire thing, and then it creates the summarization, which is this summarization that you are seeing. And then it also creates a meme. Meme is basically this image and the text placed together in a little attractive way. So this entire set of steps follow the use of LLM and automatic understanding of what is there in the data, and then basis of this, it is generating the things. Looks like a very correct architecture, and in line with the entire theory of agentic and generative AI and all those things. Now there are and just before going into the problems, just wanted to show an example system prompt how it looks like for this case. It tells that you have an access to a SQL tool. These are the rules to follow. uh, what can the tool be used for, what you cannot do, that is a guardrail, and some certain general guidelines. This is how the system prompt for this particular agent will look like. Now, these are the certain problems in this approach. Now, the first problem is the NLP to SQL translation itself. Now, the thing is that the the models have been trained on certain set of SQL queries. Okay, so in order to train a model, you basically have two set of data. One is English language, and the other is the SQL equivalent to it. And you create a long list of these kind of mappings. You will say that if I want to get the top selling SKUs, this is what it is in SQL, and so on and so forth. Now, somebody has written this basis of his schema or whatever his understanding is, may not be reflective of what is your database design. So, in my database, maybe I have to query 5 tables to get this answer. And in the database which has been used for the training purpose, it was only in the single table. Now, NLP to SQL, that is why it becomes very tricky, because it is thinking that this kind of information can be fetched in these 5 steps, but it actually needs something more. So there might be a lot of joins, subqueries, and all those things, and it becomes really complicated for the LLM to figure out, and this itself becomes a bottleneck for us. Then there is a non-deterministic behavior. As I said, that LLMs are very, very creative in nature. You ask the same question multiple times, it can give you different answers. So once the query was generated, it was not correct, it will again recreate this query. It will keep creating it as it wishes. And so suddenly this entire chain can become a very long processing step. Uh, Data privacy and leakage risk. See, if we are using the LLMs which are hosted outside, so suppose I am using a chat GPT kind of a LLM, and I'm sending all my data to that guy and then asking him to create a SQL query and getting the results back. It's a huge data privacy issue, because you are sending your data and the schemas to somebody outside, and that becomes a challenge. Then the cost of inefficiency, because if you look at it, this particular prompt is kind of a fix, because I say that this summary agent only has 5 features. Now, why I should be creating this SQL query again and again? If I have already established that this is what I want, all I need to change is the name of the outlet and some dates and stuff like that. So some parameters need to be changed, not the entire query has to be changed again and again. So this becomes a very, very inefficient way of doing it, and it incurs a lot of cost, because you are doing so many LLM calls again and again, again and again. And as I said, time wasted in the failed SQL resolution, because if the SQL was not created properly, it will again and again try to create it. So hence, this on paper it looks a very good design, but in practicality it is a very inefficient design. And I will tell you, yeah. So we will also talk about the actual cost of this design in itself. Now, let me just discuss about the challenges that you get when you go from a POC level to a production level. So one is the volume scale. Today, we deal in from Bizom point of view, we deal with around 250k users, 250,000 users, and around 5 million, 50 million outlets. So if we want to generate these kind of outputs for so many users or outlet data points, it's a huge undertaking, and needs to be properly managed, because we cannot be asking LLMs or calling LLMs so many times. First of all, it is too costly. Secondly, it needs lot of GPU power, which is not available so easily. Second is the complexity skill, because your queries itself can become very, very complicated. And if you have not properly figured out how to write those queries in the NLP form, it becomes a really never ending loop. The LLMs will never be able to understand what you are asking for. So this becomes a challenge. The second challenge is the hallucination. And I just want to make it very clear what is the hallucination and what is an inconsistency, because both are the problems. Hallucination is that when the LLM doesn't know the answer and it tries to just be creative and tell you something. So, for example, I ask a question how to set up a user in Bizom, and I know that Bizom, because LLMs have not been trained on the Bizom data, it will not be able to understand this question, but it still tells you, and it tells you because it understands that Bizom is a software, and any software will have these kind of steps, so it will just give you answer, which is totally fictitious. The other is the inconsistency. Inconsistency means the non-deterministic answer, where you ask the same question multiple times and you might get the different answers. Both of them are very crucial to resolve in the production level thing, because I cannot show a summary of an outlet where it was growing, but we are telling him that it is degrowing. So that changes the entire thing. The budgeting part, as I said, that this particular design is a very cost inefficient design, because if we just take certain numbers like 250,000 users, and the way the cost is calculated is on the basis of tokens. So how many, so tokens is roughly the words. So in how many words I gave a prompt, and in how many words I got the answer back. If I do some calculation, what I find is that I have to spend like $200 for a agent in a day. These are daily calculations. And for an outlet level, I need to spend around $2,000 to generate an agent. And today, Bizom has like 4 agents which work at an outlet level and 10 agents at a user level. So if I use this design, I'll be spending like around $9,000 a day just to generate these agents. And I am talking about a model which is really cheap. So if we go to a more advanced models, this cost is going to be like an exponential on this one. So now coming to the best practices, and this is something that we have kind of created on our own. So we say that there should be 4 R's for any agentic design, and the 4 R's are reliability, which is basically the consistency and accuracy. So you need to figure out how to make this happen. The second is the respect, which is the privacy. So the data should not be leaving the premises or the required territory. It should not cross that one. Third is the reach, which tells that your solution should be scalable from the design point of view. And fourth is the cost. And as I said, that all of them are very crucial for a production level setup. And this is the, so there will be always a situation where all the fours are not achievable, so we have to figure out which is most important for me. Maybe in certain cases the privacy is the most important part. I don't really care about the cost and other stuff, but in certain cases I want the cost to be very efficient. I don't care about the reliability because I am giving some kind of a creative answers only. So we have to figure out which is the right equilibrium for those things, and that's where the agents should be designed for. And what we do is that we always create a report card for any approach. So if I look at this approach, which I just discussed, the naive approach, as I say, uh, here is the report card. In the reach or the scalability, the complexity handling is a very difficult thing for him. Um, it can you can ask for some arbitrary queries and all those things, but nothing serious thing that you can do. So it is a good thing for entry point analysis, but not for a production level analysis. Reliability, as I said, that it is highly dependent on NLP to SQL kind of a model. So high variance in the SQL outputs you will see. uh, LLMs have been not been used in a proper way, because again and again we are asking the same questions to LLM, and trying to unnecessarily use them. And again, the data is exposed a lot to the LLMs, and hence the respect is also so. Only the reach is something that can be considered like a moderate level, but otherwise other things are not there at all. Uh, Then there are some infrastructural decisions also, and this is where the real cost benefit comes into picture. Now, if you want to use LLMs, there are three ways to use them. One is called as a third party API, which is so basically this. So I am an application. I use the APIs of OpenAI or Claude and directly call the thing. Now, this approach is the most expensive and has the most possibility of data privacy breach. And there is a high recurring cost because every time you make a request, you get a cost. Now, the other is the self-hosted, where you buy a GPU or you have a GPU on the cloud and you install something called as an Olama, or there are other VLLM kind of servers. On those servers, you host the entire LLM itself. So some version of, say, for example, GPT can come over here, and then you make the queries. This is the cheapest of the lot, but the problem is that the scalability is the issue, because unlike OpenAI, which has like a infinite number of I mean, infinite means that very large number of GPUs on disposal, and so it is always up and running. Here the load has to be really managed because you can't keep on buying the GPUs. It's very expensive resource. But for 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 a smaller experiment, this is what can be an approach. And the third is the which is the combination of the two, where you can use something like a Bedrock, which gives you a ability to either use their own models, which is hosted on the Amazon cloud, protected by the Amazon guardrails and your agreement with him, with the Amazon. And also they give you a way to talk to the OpenAI or the Claude APIs. Again, there is a access control. So privacy is taken care of. It is a hybrid model. There will be little bit cost when you go to the OpenAI or the Claude, and it will be little more because now Amazon is also getting the share of that cost. But your data privacy is there, and you also get the way to scale as you want. Uh, and there can be a hybrid approach where you say that I will use all the cheap queries which are very simple to run, and I know what is the answer by just using the self-hosted environment. And if it is a really complicated and has to uh, understand the nitty-gritties of my prompt, I will use the hosted APIs or the cloud API. So this is one decision point. The second decision point is the query strategy itself. Sometimes you can ask the LLM to generate the SQL, which we were doing in the previous example, or you can have a predefined query, and LLM can only be used for the formatting of the final answer. So that can also be an approach, and this is where a lot of determinists output will come, because if the query is fixed, then the answer will always be correct. It's only the creativeness that will be used at the later part. Again, should we call every such kind of an arrangement as an agentic or not? Again, we have come up with certain guidelines. We need to see whether any content is getting generated. So, is the output creative in nature, or is it like just a SQL query giving out the answer? Second is that, are we able to call some tools automatically? Like in the previous example, the NLP to SQL was a tool which was getting called by uh, the system. And third is the reason, or the way to understand whether the answer is correct, not correct. If it is not correct, again ask the question automatically. These are the three aspects of a truly agentic solution. Now let's see how our architecture worked on those three aspects. Generative capabilities. It is limited generation because it is only generating the SQL. It is not. So when we say generative capabilities, there are many things that should be generated. For example, there can be a plan of action that I will first ask this question, first do this subquery, then I will do this subquery, and then I will join the things. So it is not generating all those things. It is just generating that, okay, you have given me a question, and this should be my answer. um, Action oriented, yes, there is a tool call which is the NLP2 SQL call. There is no reasoning, so it doesn't know whether the answer was correct or not correct. It basically, um, it needs some human intervention to say that okay, you have to again do it because the answer was not correct. So what we can do is that how we can balance or how we can make it more productive in nature is the following. These are the two steps where a lot of LLM power is being used, and mostly it is of no use because the queries are kind of fixed. You know what you want, and the analysis should be done by you as a person who is writing these queries, because you know much more than what the LLM can help you out. And once everything is done, then the LLM should come into picture where it can summarize that details, it can create some memes for you and make the output more and more interesting. So that we called it as a balanced approach. And the if we just see the benefits, I think they are quite evident, like low hallucination because the sequels are already there. Consistency and repeatability, the answer will always be the correct because the data that is fetched is the right data. Cost efficiency, because we are using the LLMs only to produce the final output, so we know how many calls we will need. It is not that the sequel has to be generated and we don't know whether the sequel will be generated properly or not. There is a separation of concern, because this part is something that we know where it can go wrong, and this is an LLM dependent, so we can look into where the problem can occur. And finally, it is a production ready solution. It is a stable, scalable solution. Shortcomings, as you can figure out, that it is like an extreme case where we are using LLM only for the final output. So the use of the LLM is not that great. Workflows are fixed because you have the fixed SQL queries that you are trying to run, and you can't just change the output on the fly. I mean, the data will be generated whatever is written in this SQL. Unlike the other case where you can just tweak the user prompt and the answer can change. Um, but from a report card point of view, as we said, that there are two aspects that we closely look. The 4 R's, which is reach, reliability, everything is quite good. From an agentic trait, it is not that great. The only agent or only capabilities is the generative capabilities. The tool or the reasoning capabilities are not there here. So both are the extreme solutions. The actual solution, like as I said, that there is an equilibrium that we have to see what we want to do, and that is where multiple possibilities are there. So we are not going to discuss all those possibilities, but you can understand that sometimes you may want to have a better control on the changing of sequels on the fly. Sometimes you want better control on the scalability aspect of it. So accordingly, the designs will change. Uh, yeah. So the final thought about this design part is that it's actually a balancing act between three things. One is the, as I said, 4 R's. The other is the agentic trait, and third is the decisions, whether I want to host it on the public cloud, or I mean, I want to use a publicly hosted APIs. I want to use it in my on my own local GPUs, or I want to create the predefine the sequels, or I want allow the user to do it. These are the design decisions. So if you find out what is the best part for you, that's where the most acceptable solution would lie. um, Now final, I will take just 2 minutes to cover one aspect. So you may say that why are we doing all that? Why can't we just write the code like everybody else does to get this summary? Now, what we realized is that apart from being whatever agentic AI gives you, it also helps us to improve our software delivery or software development programs. So today, if somebody says that I want to change this, say for example, just a second. Yeah. Today somebody says that instead of this outlet summary, I want certain more things here. Okay, instead of showing me just the outlet data, I want to see some salesman data also here. Okay, and he can come up with all kind of crazy ideas. The person who is designing this. Now, for every change, it needs in a conventional programming, it needs the change in the business logic. It needs the change in the visualization. Any change means that you need to compile the code, you need to go into the DevOps cycle, everything, and it takes time to release the new output. But if we do it in a agentic AI mode, what we can do is that we can create these rules as separate APIs or tools. Everything can be abstracted into some kind of tools which can be then called upon using the prompts and the LLMs. And that way, now the problem, instead of coding the entire solution, now the problem has been turned into how efficient you can write the prompts. So just to give you a sense of it, suppose there is a agent which is a EOD, or the end of the day report, meaning that how your day was. Now the end of the day agent, uh, so just let me just go through this diagram. So we have an LLM that is taking care of all the decisions and all those things, and these are the tools that we are saying that we can write. So one tool is telling how much cross sell happens, another tool is telling how much upsell is happening. So these tools are nothing but some kind of a SQL query which is going to fetch the data and pass it to the agent. How many green calls were there, how many struggling outlets, and all those things. Now when I say I want a EOD agent, what it can do is that I will write a prompt here which will try to choose these three tools, okay, and create my EOD agent. Now you say that I want a user info agent. Now somebody will just create another set of prompt which is going to pick up these three things, and the other guy can say I want to pick up four things. And so you can understand that now the task is just to configure the things and release it out to the outside world. So the entire coding part has been changed into the configuration part. So I'll just end over here, and if there are any questions regarding this entire thing, I will be happy to take, maybe after the demo, um, if the time permits. Yeah, over to you.
Thank you so much, Rohit sir, for that very informative session. I'm very sure everyone in this session has taken away at least some new insight that they didn't know before. So far, we talked about what agents and agentic AI are and why they matter in a complex, high velocity CPG environment. The obvious next question we usually get is, what does this actually look like in day to day operations? How do these agents help a sales manager, a regional head, or a frontline team make better decisions today, not in a future roadmap? To make this concrete, I'd like to switch from concepts to a live example. What you'll see next isn't a generic AI demo, it's how agentic AI is already being applied inside Bizom, quietly handling complexity in the background. We'll walk you through two examples: a summarization agent that turns raw execution and sales data into clear, decision ready insights, and RI Copilot, which helps managers ask better questions and act faster in developing markets across the world. This is where agentic AI stops being an idea and starts becoming a part of everyday execution. Let's show you what this looks like in action. I will now be handing it over to our product expert for a live demo. I would like to introduce Mr. Sharad Nair, who is the Associate Product Head at Bizom. He works on defining and scaling product features that translate real-time retail and distribution data into experiences for sales and operation teams, helping accelerate adoption and impact across markets. His work bridges user insights, business value, and technical capabilities to deliver products that solve real world execution challenges for customers globally. Over to you, Sharad.
Thank you, Anushka, for the wonderful introduction. Hello, everyone. So today I'll be taking you through the agentic user journey for a salesman on the ground. So I hope you guys are able to see my screen. Uh, yeah. Cool. So guys, I will start from the day beginning, from how in the morning what a salesperson does and how he would go about his day-to-day journey along with the agentic AI in his hands, right? So at the first start of the day, we have the attendance marking. So most of the companies and the brands have some certain criteria of time and place in the market to when to mark the attendance. So I will just show you how the attendance agent and what are the AI features that we have in the attendance flow marking system. So first option that I have here is to take a picture. So if you see this, we have a human detection algorithm inside the attendance module. Basically, if I show something else, if I show a wall or something which is not a human, I'm not able to take my attendance, right? It asks me to retake the attendance image. But as soon as it detects my face, you can see it turns green and it shows that face is detected and it will proceed me to mark my attendance. So currently, this is at a human detection level, and we are also working on a facial recognition feature where it will automatically recognize if it's the actual person who's marking the attendance. So once I click my picture and I click the present, it also asks me what are the type of visit or what is my plan for the day. I choose what is my plan for the day. Let's say market visit. If I want to add some remarks, that is optional. I click in confirm. So our Rio agent shows me have a great day. And once I mark my attendance, what it shows me is what is my upcoming day looking like, right? So today's beat is Manila North, and I have 7 outlets in my particular beat. And it gives me some kind of a motivation and also gives me a context of what I did previously in my beat on this particular day. So yesterday I have visited half of the outlets, as you can see, read the text here, right? And I got a sale of 11.3K rupees. So it gives me some kind of a motivation, also gives me some kind of text about, what I did previously, how I can improve and things like that. So this is also very context aware agent in the sense that this is very personalized pitch according to me. As Rohit mentioned in the previous session. So this takes the context and we use LLM to bring creative insights to the person based on the data of that particular person. So if somebody else logs in, he's going to see information specific to that person and specific to their day, right? So I see this motivational message at the start of my day. I click on let's start the day, where I reach my outlet list. So this is my list for that is the outlets that I have to cover for the day, right? I also see an chat agent here, which shows me if I want to need suggestions and things like that. So what this helps me, if I click on this, is it gives me some idea about what is my particular beats outlets, what are the kind of information that I want. For example, who are my top performing outlets, right, which I need to visit for sure. Or the question could be, what are my outlets which I have not visited in the past 2 months and which I really need to cover today. Now, these questions and these suggestions are also specific to vertical, industry, and the user. It is very context aware so that we are showing the right kind of questions to the right person. Now, the another flow that we have here is, as you can see, I have a bunch of outlets. So one main problem that we've seen across the industry is that, particularly with respect to salesmen who are new to the market, what we see is that they do not have much of an understanding about how to cover their outlets. What's the most optimal way to cover these outlets, right? If they're not. So in that sense, we have our optimizer agent. So if I click on this optimized beat, it gives me an available optimized list based on available hours and current user location. So what available hours is that if I have a few hours in my day, then what is the best outlets to cover? It shows me that. And if I go by my current location, what it does is it optimizes my whole outlet list as per my current location, which is the outlet that I have to cover first, and it sequences it out based on the real-time geolocation. So as you can see on the screen here, I have things at 0 kilometer away, which are right next to me, 0.13 kilometer, 4 kilometer. So as you can see, this has sequenced it according to the distance from my current location and what is the most optimal way to cover my beat. right? So this is my optimizer agent, which helps me cover my beat or cover my customers in the most optimal way using real-time location data. Now, coming on to that, now let us go to the step where I am going to visit an outlet. That means I'm going to visit a customer and I'm going to maybe punch an PO, punch a sale, punch an order, right? So I'll go to this neighborhood wholesale, which is my outlet, which I have, to go. And what I can see here is that whenever I go to that outlet, the agent gives me a summary. Now, what does the summary say? So it says that the outlet experienced a peak in October, a decline in November, and recovered in December. So it is also giving me some kind of a recommendation to prevent degrowth. So it shows me that focus on promotional activities, analyze customer feedback from November to identify issues, and enhance inventory management to prevent stockouts. So the Rio is also suggesting me at an outlet specific contextual level that what has happened in that outlet, what is something that I need to focus on, and how do I improve my sale. And if I go to a different outlet, it's going to give me a different kind of an input. So for example, I go to Shubham Kirana Center, right? It shows me there is a decline and sharp in November and significant growth in October. So as you can see, different outlets are going to give me different kinds of inputs here on the different summarization engine. Now I will go and start my call here. So what I mean by start call here is that I'm going to punch the order against the outlet. Just a moment. Yeah. So let me go to order if I want to place a pre-sales order there. One okay. And I go to my order. So now guys, here is my Copilot, which comes up for me. As you can see, during the order placement flow, that is, as you guys know, the most time of the on-field users is spent in this screen as we analyze in our app. So our goal here was to understand how we can enable a sales Copilot to the user that is going to help him in his day-to-day activities. How do we make this process much faster and also provide him very intelligent insights at the right moment, which is very contextual aware. So once again, there we have a summary. We have a chat agent here in the Copilot. If I need some suggestions, I can click this. So it gives me some kind of outlet specific data. What are my slow moving SKUs? What are my fast moving? What are my top selling? Once again, these questions would depend on the industry, would depend on the outlet, would depend on that specific context of that person at that point in time. Moving on, if I go to my order, as you can see here, I have some filters here, right? So if you look at this Dunhill switch, for example, I see that I have a bunch of suggested quantity. Now, what is suggested quantity? It is the part of a regular order. Now, what this suggests or what Rio is telling me here is that on a regular day, I am easily able to sell this quantity. So I do not, as a salesperson, need to think what to place, how much to quantity to place, because system is automatically recommending me what is the most ideal suited way to add this. So I click on plus icon and my quantity gets filled against each of these SKUs. Now I have something also called an upsell. Now upsell is something that which the system has found out that usually maybe I'm placing lesser quantity, but I have a big opportunity to place more quantity or upsell this particular line at that particular store. Now this is once again based on the similar data trends across that outlet. What are outlets in those areas buying, and what are the similar type of category of outlets in those areas? How much do they buy, and is there a scope for improvement for this particular outlet when we compare it to its competitors, right? Now another is cross sell. So what cross sell is, basically it helps with placing new line items onto the store. So this has a direct impact on LPSC, where we have analyzed that the similar outlets in the vicinity of the similar type are buying these products, but you are not buying this product, right? So this gives the opportunity for the salesperson to increase his stock lines at a particular customer. Now, product recovery is something related to if I have sold something, but I have lost the shelf space there, and now probably some other competitor has come into my place, and I do not have that particular SKU in the store. So the system is automatically going to suggest me to recover that particular line item here. Now, as you can see, I have a lot of SKUs and line items. So one thing we've done here is a one-tap order mechanism. So if you see on the top right side, if I click on this blue hand icon, what it gives me is that it pre-fills me all the system suggested quantity, what I'm supposed to order for this outlet, upsell, cross-sell, product recovery, and I can do it in a one-click add to cart. Now, as you can see, this whole process has made the salesman's life much easier. He doesn't need to, think about what to place or what to say, because the system itself is suggesting him what is the most optimal thing to be placed here. Right. So now once I go to cart, I can also see that what are the things that I have added. So one thing I would like to show you guys is if I go ahead and not place any order here. Just a second. So if I go to my add order screen, that means if I am going to sell my close my outlet without doing any order, in that particular scenario, just hold on. Yes. Problem with my location. So if I go to this particular add order screen without me placing the suggestions what I was supposed to place in that outlet, our agent also gives a reminder to him that before you close the call, that means before you leave this outlet and close the call, you have missed these kind of things, and you can remind the retailer about this. So it is suggesting that people around you are buying this, so why don't you give the outlet a chance to purchase these outlets? So once again, this gives me an add to cart opportunity, and a reminder that why not place these items before adding to the call. So the summarization agent also shows up here, and I get this add to cart details for those particular things. So it is kind of a reminder, once again, contextually aware based on the user's action, based on the outlet history, and based on the competitors' data around that outlet in the geography. So this is the ad order flow for the salesperson, which we have made much simpler, much context aware, and much more intelligent compared to his previous non-agentic or non-AI call summary details. The next agent that I would like to show you guys is I also have agents here in my main menu, which gives me month over month growth. What is my total monthly sales value? What are all these details? What I need to capture. Now, another interesting agent that I would like to show you guys is my info agent. Now, what is my info agent? If I go to the info screen of my particular user, what it shows me is it shows me a concatenated summarized view of productivity as of date for this month. So as you can see, what is my top SKU for this month? How many orders did I place? I placed 4 orders today in this month, which is actually 20 less than December 2025. So it also compares the productivity and also gives me some kind of pinpoint actions that I can do to improve my productivity and improve my order value and achieve my targets, right? So it tells me what SKU is I'm supposed to place because it has a higher potential. Once again, because I know the data across all the customers, I can suggest to this user what exactly needed to be done here. So this is the my info agent that gives me the overall snapshot of what I'm doing throughout the day. So guys, this is basically the all the the agents that we have in live and which is currently on the field helping our users go on by the day in a much improved manner. Over to you, Anushka.
Thank you for that great demo, Sharat. Let's open up the floor for questions. We've noticed some in the chat which we'll be addressing. So over to you, Rohit sir.
Okay. Yeah. Can you hear? Yeah. Okay. So I saw a few questions. Two of the questions I will just try to explain using a visual diagram itself. So there is a question regarding how to analyze the merchandising images and summarize them using say agent. And similarly, there is another question regarding a repeated task for data. So let me just share the slide. Is my slide visible? Okay. So so both the things can be done using the simple steps. So for example, in the merchandising case, you have a image that is coming from the say shop, and you want to analyze this image, and then you want to tell or create a summary out of it, saying that these are the things that I saw, or these were the number of facings that were available. So basically, your prompt is simply saying that analyze this image and try to create a summary where you are listing the items which are available. Assuming there is a tool or an some kind of a image processing API that can take this image and analyze it. So the LLM is going to just call this tool, and whatever data comes, so basically this data will be in the form of some kind of a structured output that we call like JSON or XML or whatever it is. This output will be taken by the LLM, and again a final summary will be created. So the image will become your input along with the prompt, and the tool is a image processing tool. Similarly, there is a question regarding what can be done for the data repetitive stuffs. And if I understand the question properly, there is some kind of a data that needs to be put on a slide every day, or maybe once in a week, as kind of a report. So again, this data comes, and you have a tool. So PowerPoint or all these visual tools these days can be linked to using the MCP layer. So as I explained earlier, MCP is a new way of connecting to the APIs through the LLM. So LLM needs to have more language oriented API definition. See, generally the API will be is create slide, but it doesn't give good sense to the LLM what exactly is create slide. So that API will have some description that if you send me the data in this form, I can create a output in this format, and you should always call this function when you want to create a slide. Suppose this is a kind of a description written. So LLM can now call the MCP layer and say, give me all the tools which are available for designing this data output, and it will give one tool which is related to PowerPoint, assuming all these things are available to you. And then you can just simply pass this data and saying that I want the data to be split into a table, and then some kind of a summary to be written, and this can be created automatically. um, if I'm suppose this was the question, if I am wrong, please correct me. um, then another question was related to are these summary agents built by Bizom? If yes, how the data set is curated, and things like that. So yes, these summary agents have been totally created by Bizom. And see, there are two things when we say model training. One training is when you train the model from scratch, or basically improve the capabilities of the model. We are not doing that, because if you see what we are trying to use the model for, we are trying to use the model to aggregate, or to create a summary of the data, to write a SQL query. These kind of tasks we are trying to do. These tasks are already available with the publicly available LLMs. So what we do is that write the proper prompt that can help the LLM to work according to our needs. So this is what we are doing, and this is what 99% people are doing, because training an LLM is a very very expensive task, and really not needed, because most of the data is already available to them, which you can use to get your work done. Uh, then the question is, would this agent work for workflows where orders are not taken from Bizom, but the data can be ingested on the? Yes, definitely. So we showed you an order workflow because that is what Bizom generally does. But there are use cases. So as we mentioned just now, that a use case could be just that a image is sent to you and you are analyzing and then giving out an output. How many products of your choice are on that shelf? That can be an output. or anything. I mean, data can be in any form, output can be in any form. All you are using LLM is to analyze the data and create a output for yourself. um, um, then yeah, I already answered about this on-prem GPU using DeepSeek family. You can use, actually, see, the choice of LLM is dependent on what kind of intelligence you are trying to get from it. If your output is only to write a good creative English sentence, all the LLMs can do. Any LLM you pick, it will be able to do. If your need is to the LLM to think about it, so you have asked a question and you have asked that, give me a step by step output. How did you arrive to this thing? Then you need the LLM which are called as thinking LLMs, and DeepSeek is one of them. Then you need those kind of LLMs. So related to your problem, your choice of LLM will be there, and yeah. Um, I'm not very sure on this question, which Toshpal is asking. Would agentic AI enforce decisions across independent stakeholders? If you can elaborate more on what do you really want? And this, yeah, I already said that we are not. So we are using pre-trained models, and those models are getting the behavior of those models is changing using the system prompts and the user prompts. So that's a very standard way of making the LLMs work according to your needs. Um, yeah, I think I answered all of the questions. Yeah, so sure.
Great. Thank you, Rohit sir, for that. And all of you who are attending this webinar, I hope you all learned something new today. And if you'd like to explore how RI Copilot can work for your brand as well, you can drop me in the chat box. We'll reach out to you shortly. We'll also show you a QR code which you can scan, or you can head over to our website, bizom.com, and request a demo that is personalized for your brand. Stay tuned for more sessions like this. I hope you have a great day ahead. Thank you, everyone.